So, hi everyone, and we're coming to the next highlight. Today it's Kevin from Spotify. Kevin is a director of engineering at Spotify, and he leads the player tribe. So every time you launch up the player, it's Kevin or one of his team. Spotify has been tremendous, I think, in publishing how they organize their engineering org. Last time we spoke, I think it was 700 engineers. I guess by now it's 800 or something, or even further. So they are really experts in how to scale organizations. We've been learning a lot from them and implemented a lot. We have squads, tribes by now, guilds. Right, and I want to mention one funny story here about Spotify. Everyone at Stylight uses Spotify in their daily, during their daily work. Everyone got the Spotify flat rate last year for Christmas. It was one, because we liked the service, and two, because we could reduce the internet bandwidth by 10%. Previously, people had been streaming YouTube playlists to listen to music, so this was a really a win-win. Better service quality, better internet quality. So let's hear from the man that built it, Kevin.
Thank you. Thanks a lot. I'm going to tell that story over and over again. That we can help reduce. We're not just a product for consumers. We're a product for businesses as well. We can bring down your streaming costs or your internet bandwidth costs. Wow, it's good to see everybody. How many of you are familiar, like have read the white paper or know a little bit about how Spotify does stuff? Okay, good. Good, because I'm not really going to talk about it, but I was just curious. I will touch on it a little bit in this talk. This is not a talk about how Spotify does tribes and that kind of stuff. This is a different talk. But I should actually just check, like how many people are aware of Spotify or know what Spotify is or use Spotify? Cool. All right. The rest of you, come in. I actually just met with, we just had our product strategy meetings the last couple days, and one of the things we have is an economist, Will Page, and he's an actual economist, but he works a lot in this area, and he was talking about Germany specifically, because Germany is a really weird country. You guys still buy CDs, and it's really strange. A lot of CDs. But you don't buy iTunes, which is also weird. You guys went straight from buying CDs to streaming without buying downloads in between, but you still buy CDs. You buy CDs and you stream. Anyway, so what this talk is, this is a talk that I call apportioning monoliths, and actually I didn't realize when I decided to do this talk that the speakers prior to me were also going to talk about monoliths. I'm also talking a little bit about monoliths. Apportioning monoliths, if you don't know that word, which most native English speakers probably don't either, means breaking up monoliths. This talk isn't specifically about breaking up monolithic code bases or breaking up monolithic backend services. This is just about breaking up big things and making them small things, and then how that actually makes a lot of stuff better. So the first thing we're going to do here is I'm going to do sort of a thought experiment. Let's say I wanted to build a large application, okay? Big application. There's some requirements for this application. I don't know if you can read this, but hopefully the monitors, and there's not that much detail in the text. Some requirements for this application: it's got to scale to millions of users, right? What we could call internet scale, web scale, lots and lots of users. It's got to support multiple platforms. When I say multiple platforms, I mean it's got to support web, of course, but it also needs to support desktop, mobile, tablet, PlayStations, cars, watches, lamps, speakers, handle complicated business rules, really complicated business rules, not your simple kind of business rules you might be aware of from commerce and stuff like that. And it's got to be competitive in a really fast-moving environment. And when I say competitive, what I mean is, to me, that really means two things. One is, it means you need to be able to react quickly if your competitors do something, right? So you've got a cool product in the market, one of your competitors comes out with something better, and you need to be able to react to them and get back out into the market to stay competitive. But even better than being reactive is being proactive and making them chase you, right? So you need to out-innovate your competitors so they're always following you or doing crazy things like making a radio station. And of course, I think I just hit my hat. I'm thinking of a product like this product being Spotify. This is the product I've been working on for a while. You really can't see it on the screen, but it's beautiful. So what you heard a little bit about is I run the music player tribe. It's about 120 engineers, testers, coaches, POs, designers. We're the ones responsible for the mobile, desktop, web clients that you use, most of the features, all the back-end services that support them, and all the streaming, ingestion from record labels and streaming to clients. This product, as we announced this week, has 75 million active monthly users. One thing to understand about Spotify versus like a website, like a newspaper website or even Netflix, people don't use us for 5 minutes at a time or 10 minutes at a time. People use us for 8 or 12 or 14 hours at a time. So an actual session is usually in the multi-hour range. People listen to us all day at work. People actually listen to us while they sleep. I'm not kidding. Like some of the crazy things about Spotify, there's a ton I could do just a talk on the weird things that people listen to, but one of the things people will listen to is white noise. Like some of our most popular tracks, like right up there with Kanye, is like white noise. And people stream it all night long. We're available in 58 countries. This is an old number, but the numbers from now on, these are our last published numbers. The 75 million number we announced this week, that is absolutely up to date. These numbers are old. Assume much larger orders of magnitude at this point. Over 20,000 tracks and now videos and now podcasts being added every day. So our corpus is over, our catalog is, 40, 50 million tracks now. 30 million may be available to you in any country. We have over 1.5 billion playlists created by our users. Again, this is a really old number. Imagine this number is significantly larger. And we have ridiculously complicated business rules like you can't even believe. I don't know how many of you know anything about the music industry. Does anybody work in the music industry? You and you. Okay. The rest of you, it is ridiculous, this business. You would say, like you see, Spotify has licensed Warner's catalog. What that means is we've licensed Warner's catalog in every country we do business in. Right? You can't go to Warner and say, please give me worldwide licenses. You go to Warner US and you get the US licenses. And then you go to Warner Germany and you get the German licenses. But you also have to deal with GEMA, who is the Publisher Society. And there's a different Publisher Society in every country. And there's a different version of Warner in every country. And every one of them needs to get a bonus this year. So they're all going to negotiate differently with you. So that's a big deal to get these licenses. But what that also means is when you have that Kanye track that you're listening to that appeared on this album that everyone heard, what you don't realize is it appeared on 55 different albums because every country had a different version of that album. And then it was also on compilations, and then it's just crazy, the business rules. And then you have to pay all those people, right, based on where it gets played. Very complicated business rules. And there's a lot of competition, right? We're doing pretty well. In this business, but it's an incredibly, incredibly competitive business. There's some companies you may have heard of. The latest launched this week. They are all, some of them are smaller, and they're trying to get us, and they could be more nimble because they're smaller, right? And they don't have some of the stuff that we have to deal with because of our size. Some of them are literally the biggest companies in the world. Apple and YouTube we're in direct competition with them. So this is the world that Spotify exists in. And we have to thrive in, or we won't be around anymore. So how do you tackle all these requirements while also moving fast and innovating? We need to be always in front of them and not chasing them. Agile. That's one way. How many of you work Agile every day? Awesome. How many of you have ever worked waterfall? Non-Agile. Okay, good. So I'm going to talk a little bit about Agile. I'm not going to talk about Agile processes. I'm not going to talk specifically about how we do it at Microsoft. At Spotify, I'm going to talk about Microsoft, but not, you'll see in a second why I made that slip. Anyway, by the way, I also changed these slides on the plane, and so I may get lost somewhere in here, because I also flew in this morning, which meant I woke up at 4 a.m. Like there, I just did that. So just so you know, so we're a company that was created. We're the children of the Agile movement. I'm a little bit older, but Spotify as a company started Agile, has always been Agile. And this actually makes us significant. Working this way has been a significant aid towards being competitive and being able to work that way. For those of you who already work Agile all the time, at least I'm going to give you a little bit of cool stories that you can use to convince other people in your team who are maybe not that enamored of Agile working. For those of you who are not working Agile, maybe I can help give you some ammo to take back to your team. This is just one section of this talk. I want to go into history a little bit. I've been working for a long time. I'm old. And I started at Microsoft Microsoft was not my first job, but I started Microsoft in 1994, before Windows 95 shipped. That's how long I've been doing this. Back in the day, what you can't see, or maybe you can sort of see here, is there's a line there. There's a way we made software when I started writing software for a living. There was this line. This line is a calendar, and what the text you can't read here is, actually I can't read it either, product release calendar, right? So I worked on Windows. That was one of the things I worked on at Microsoft. Windows was a multi-year software project, right? 2 years, 3 years. The minimum piece of software, the shortest schedule I had when I worked at Microsoft, and I was there for 8 years, was maybe 14 months, right? That's from starting to releasing. So imagine this is a 2-year Windows release cycle, right? The way we used to work, and the way hopefully no one works anymore, but some do, we'd start this with spec. We'd spend 4 to 6 months writing a specification of several hundred pages. And that was just for our part of the product, right? That's not the whole product, that's just our little piece of it, right? For my team. This would be debated amongst us, and then we'd go up to the next level of management where everyone would bring them up, and they'd all fight. The product managers would fight, and then they'd make changes, come back to us, we'd rewrite it, go back up, come back down, go back up to the next level, come back down, go back up, come back down, go back up, for 4 to 6 months. And at the end of that, we would literally have a signing ceremony where the VPs would all have like the massive book of the specification for Windows or whatever, and then they would all sign the front page, and now the spec was locked. No more changes. We're ready to go. So then we'd start to write our code. Right? We'd actually, developers, we'd be cheating because we'd be fixing bugs during the spec process, but we really wouldn't be able to really start writing code on the product until those 4 to 6 months were complete. So we'd spend maybe 12, 14 months actually writing, and we'd write to that spec, because that spec had to the pixel, to the right click, to the left click, to the control characters, what every part of everything did, right? So that was what we used. And sometimes during that 12 to 14 months, this idea you had way over here, this is going to be awesome. No, that was a horrible, horrible idea, but you discovered it around here. The problem you have then is, well, you can't change it because the spec is locked. Like, there's people's signatures on it, right? If you want to make a change to that spec, you got to open the spec, and there was a process for opening the spec, and that meant getting yelled at and then having to do the entire fight all over again. meanwhile, you don't get back to moving to there. So you never wanted to reopen the spec, but sometimes you had to. But mostly what you do is just say, well, this was a horrible idea that I had here, but now I'm going to code it here because I can't open the spec. So this is a dumb thing. What would also happen somewhere in here, there's a 2-year cycle. Somewhere in there, your competitor comes out with a really cool feature. And you go, well, crap, like we should do something about this. This is way better than we're doing. Oh, but spec's closed. Like we can't add that feature. I mean, we have plenty of time. We just can't really do that because then we'd have to reopen the spec. So you'd say, that's cool, we'll get it in the next release. Of course, the next release was 3 years later. So we do this, spec 4 to 6 months, code 12 to 14 months, and then cool, like, all right, we're done. No, now we test. Honestly, we were testing in here, but we weren't fixing anything because, oh man, we had to release the entire spec and be done over there. So no, that's when we actually start fixing bugs. But of course, by the time you're here into testing, you've already paid for Hollywood celebrities to come to your launch event on a very specific date, which meant that you were releasing at the end of this line no matter what. So this is the amount of time you have to fix all the bugs. That time doesn't change because the other part of this was back then we would also have to manufacture CDs or DVDs, print up boxes, put CDs, DVDs in boxes, ship them into stores around the world, and stockpile them for the launch event that was going to happen at the end of that. So this part was also a big deal because when you release Windows, especially in the 90s, you are basically booking the pressing plants across the world and you are paying to hold them in reserve, which meant if you were any way late, you are now just paying to keep them open and doing nothing. And that was extremely expensive. And this is the way we used to work. This more or less represents the amount of time we'd spend in each phase of the waterfall process. The good part about this, though, there was a good part about this. If this is sort of like their product innovation scale, right? This is the time scale. This is the product innovation scale. The cool part about this was that you would know at the end of this, certainly by the end of this spec period here, you'd know how much innovation you're going to get at the end of it. Because, man, you'd already written down every pixel and how everything worked. So this was a pretty knowable thing. So that's actually, was one of the benefits. Now, of course, for me personally, all the downsides way outweighed all the benefits. So eventually I left Microsoft and I went to a startup. And at the startup, I was leading a development team there, and the architect who I was working with had just read this book called Extreme Programming by Jeff Sutherland, which had just come out. This was the late 90s. How many of you have ever heard of XP? Awesome. Oh, wow. Actually, wow. You guys are old. So for those of you, especially those of you who are around, that was like one of the very first agile books. And having come from this kind of world, he's like, hey, I would like to try this. Can we try this? And of course, I was like, anything other than this, nothing can be worse than this. So yeah, let's try it. There's a lot of good stuff about agile. There's a lot of good stuff about XP. I actually really liked XP. But the thing that I thought was the most awesome part of working in an agile way was that you took this 2-year cycle and you brought it down to 6 weeks or 4 weeks or shorter, or even 3 months is better than 2 years. And at the end of that, you have either something you can ship or at least something that's ready to ship. Now, that makes a big difference, right? So you go from this big arrow to this much smaller arrow. Now, at the beginning of this 2-year cycle, let's say as we were building a new product, we had an idea what that product was going to be at the end at 2 years. We had a vision, a product vision. And so when we started working towards that vision. Now, unlike here, where you get no feedback, or worse, you can't change anything even as you learn, Because of Agile, you can learn and adapt as you go, which meant, sure, the first iteration, we were very much on the same track. The second iteration, hey, this idea we thought was going to be awesome, that was a really stupid idea. Let's fix that. Let's do it differently. Now maybe we're actually going into the market, and we have a first release for users, and the things that you inevitably find out when you release a product is the thing you think users love, they hate, and the things that you think they don't care about, but maybe it's a thing for you, they love. So now you've learned a lot more. So now you're adjusting because you're learning, you're adjusting because you're learning, and at the end of the same time period, you actually have a much more innovative and interesting and product with better product market fit. So, one thing, I will tell you, I worked on Windows, I did not work on Office, but I was also in research for a while. I knew the guys who did Clippy, right? Who did the Microsoft Office Assistant. And these were incredibly smart people. I mean it. These were PhD people in research building this technology. They, of course, thought they were building something cool that people would like. No one's going to build something they think people will hate. But it took a lot of work, right? This is, it was more than one release of Office. So they worked on it for years, thinking the whole time, man, this is going to be amazing. People are going to be so happy when they see this. And of course, that's not really what happened. And they didn't learn it till, here. But there was a bunch of time spent that maybe they could have learned, what, a paper clip is a stupid thing. Maybe we should do something else. And they might have actually made a better product that people would have loved. But because people hated it so much, and it was another several years to do anything about it, it really just ended up dying. Winston Churchill said this, and I love this quote, to improve is to change, and to be perfect is to change often. So when you work on, as we used to in these really long timelines, it's really hard to change. When you can break those timelines up into smaller pieces, you have a lot more opportunities for learning, and it's all about the learning that helps you actually create better products. Now, I started doing Agile at the end of the 90s, and I thought it worked really well, but I was running a team of like 7 people at the time, right? I was the XP coach for my little team and the development manager. And I, even at that point, said, well, this is cool for the way we're working, but this is never going to scale, right? You can build like Windows this way. So, I thought, coming back to my original thought experiment, I thought you said you wanted to build a large application. That's where scaling Agile comes in. Now I'm going to talk a little bit more about Spotify and the way we've solved the scaling Agile problem, but not get too deep into it. Spotify is a connected application. And that's the way I describe it, right? There's clients, the clients talk to web services, the web services talk to data. You can switch from your phone to your tablet to your PlayStation. In fact, you can control your PlayStation from your phone, but in the end, they're all talking to the same backend. I built at Adobe, I left Microsoft, or I left my startups, went to Adobe, and there, one of the last projects, I was there for 9 years, one of the last projects I worked on was this thing called Adobe Revel, which still exists, but probably not for much longer, thanks Google. It was a connected photography application, so yeah, Google Photos probably will finally kill it. But if you were going to build a connected application now, like I've done a few times, you'll probably start with an architecture that looks like this, right? Bunch of platform teams, right? Like in the Revel case, like this was iOS and desktop and Android, web. We had a set of core libraries to abstract all the business logic on the devices and on the desktops. Those handled all the server communication and synchronization. Services ran on top of an infrastructure that was a shared infrastructure. This is obviously a very simplified version of it, but this is a pretty obvious way to do this. This is how Spotify started as well, right? So before Spotify had tribes and guilds and all that stuff, Spotify was had a very traditional architecture that looked very much like this. But Spotify was also agile. This is a very hard way to work in agile. There's a few big challenges, especially when you have lots of teams. One of them is synchronization, right? So going back here, platform's on top of the core library is talking to the server sits on infrastructure, right? So here, you have the client UX implementation, the client teams. Well, those depend on the core library implementation, which depends on the server implementation, which sits on the infrastructure implementation, right? That's a lot of dependencies. The other thing that also is a big challenge, not as much as synchronization, but is alignment. And when I talk about alignment, I mean you have a whole bunch of teams working. They're all working towards the same kind of North Star. That's the way we talk about Spotify, same North Star. They're all going to the same product in the end. So these are the big challenges you have, and there's been a bunch of ways people have tried to solve them. For synchronization, what we did at Adobe actually works in an agile way, but we took a very different approach to solving that problem, which is we had Scrum of Scrums, where Scrum of Scrums, because we were mostly working in Scrum, or Scrumban, is where, if you don't know it, it's where you send one person from every team up to a bigger meeting where you all talk to each other and synchronize every once in a while, once a week or something like that. But at the scale, that only goes to a certain scale. At Adobe at one point, we actually had on Photoshop Scrum of Scrums, right? So if you imagine the synchronization and communication, when there's like that many levels, it doesn't work very well at all. If you're familiar with SAFe or the scaled agile framework, they have something called potential shippable increments, and they do release planning on those. Those are like 3-month, possibly like blocks, and at the beginning of that, every agile team makes a commitment to what they're going to ship at the end of that release, right? And if that sounds like waterfall, it is. It's very much waterfall. I call it Scrummerfall. I didn't make that up, but yeah, I mean, it's basically if you're making a commitment to delivering something on a date in Agile, you're not doing Agile, in my opinion. Sorry. The other thing that we would also try at Adobe a lot, or other companies I know, we'd all put our sprints on the same calendar days. So 3 weeks, everybody do the same 3-week sprint, for example, as a way. And then at the end, like you wouldn't do a lot of synchronization steps in the end, but at the end of it, you'd say, well, here's where I'm at. Where are you at? Okay, so now I know where we kind of check in where we were all at. That doesn't scale very well either, obviously, but also some teams like working in 2-week sprints, some teams like working in 4-week sprints, and some teams like working in 5-week sprints. And the last thing you want to do is like kind of punish a team and make them work in a way that's not natural to them just so you can kind of synchronize. The alignment problem, as I said, is more about communication. That's easier to handle. I'm not going to go into depth on that. So Spotify had this problem as well, right? We had lots of teams. We were building a product together. We had that really kind of standard architecture, and it wasn't working for us. We needed to be fast. We wanted to be fast. That was the most important thing to us because we knew that this was a competitive industry and the best way to win was to be more innovative than our competitors. So those models weren't working for us. So we came up with a different model. This is the one that people talk about us most now, which is autonomous teams. And when I talk about autonomous teams, especially for those of you who don't speak English as a native language, this is the definition of autonomous, but don't worry about that part, just look at this part, having the freedom to act independently, which means all of our teams have the freedom to act independently, and I'll talk about what that means. But the important part of that is if every team is acting independently, they don't have to synchronize with anybody else. So we completely removed the synchronization problem. Not completely, but almost completely. We minimized it as much as we possibly could. So coming back to this kind of pretty vanilla connected application architecture, if you think about just the synchronization points here, the dependencies, the platform teams really have these dependencies on the core library. core library has a dependency on the server, and the server has a dependency on the infrastructure. Now, let's say that you say, well, no, we don't want to wait on the core library team to implement the server communication. So we're actually going to go and we'll talk to the server directly. Oh, and then, you know what? We want all of the apps to have the same sets of features launching on the same day. Now you have a tremendous amount of synchronization bottlenecks and decision-making points, and everything has to be negotiated, even with autonomous teams, and that's a massive drain. If you think about Amdahl's law, right? The fastest part, your system's only as fast as the slowest part. If everybody's dependent on the core library, and in Sweden, by the way, we get half a year of parental leave, both parents, and one of the core library people has a baby, this team now becomes the slowest team in the company, and everyone's dependent on them, which means nobody ships on the cadence they want because somebody's had a baby. That's not a great way to work. That's a horrible way to live. So this was the problem we had with the existing model. Because we are students of culture and students of leadership, we, of course, knew about Melvin Conway. I hope you may have heard of Conway's law. This is Conway's law, which is that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And another way of saying that, this, when I see this, looks like this to me. Right? Whenever I see an architecture like that, I see a very hierarchical command and control structure, because that's the kind of structure that produces an architecture like that. And by the way, this was also Spotify's organizational model not that long ago, before we made this change. And it was Microsoft's, and it was Adobe's. And all of us had a very similar architecture. So what we needed to do was inverse Conway maneuver, which is my favorite thing in the world to say. Which basically means, look, like, you don't want to have all these bottlenecks, but the bottlenecks come because it's a natural way to organize your code, because it's the way you've organized your teams. If that's not the way you want your code to look, change how your teams work. And that's what we did. We went from platform teams to full stack autonomous teams. So we went from this to something that looks more like this. Oops, jumped back. Okay. So what that means is, instead of having these kind of, here's the iOS team, here's the web team, here's the desktop team, instead we built feature teams. Those teams own the back-end systems for their features, the front ends for their features on every platform. The testing, the design, the product owners are all in that team. And they own a feature soup to nuts, as we say. The cool part about this is, okay, so there were all those dependencies before. Now there's still, kind of a light dependency on infrastructure. We have to run on infrastructure. We don't want the teams to have to build their own data centers. We have a lighter dependency on the platform teams, because the platform teams aren't building the products. They're just stitching together the features and releasing them, which means that these teams really have very, 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 very few things holding them back. Certainly not decision-making, and definitely not synchronization. So for us, it increases the learning opportunities as well, and I'll explain. So if this is your architecture, this kind of standard architecture, and by the way, like, I managed an organization building this architecture, right, for a while. The cool part is, well, you got a big infrastructure team, and like, they're going to do stuff, because of course they're going to do stuff, and they're going to improve infrastructure and innovate in infrastructure. Again, the server team is going to be doing that. The core library team and the platform teams are all they exist to innovate. It's not that we're saying they can't, but they're going to innovate in bigger chunks, right? Because they're going to have a 3-week sprint or something. They're going to do a big piece of innovation, right? Working together. That's awesome. But now you're taking you've gone from taking 2-year bets to taking 3-week bets. That's much, much better. But those are still big bets. What if you could instead take lots and lots and lots of smaller bets, right? So now what you have is the iOS developer in the search team is doing something cool on iOS, and he's one person, so he's going to do it little time. But at the same time, the server developer, she's doing something awesome. But again, it's small because they're working on their own or working in a very small group. What we did is went from kind of these large scale, big pieces of innovation to lots and lots and lots of small innovation happening everywhere. We went for throughput over velocity, innovation throughput over velocity. That actually works incredibly well because if you think about all the learning you're doing in lots and lots of places, you're finding part of learning is failing, right? And you're failing all over the place. You're making bad decisions, but all those decisions, we minimize the blast radius. So you're not making bad big decisions, you're making lots of bad small decisions, but you're making also lots of good small decisions, and you're learning from your users. So this works really, really well. This is the way we work. This works incredibly well for our steady state, right? Just day to day, getting stuff done. So I don't know if you heard a few weeks ago, but we are now doing video, and we're doing podcasts, and that is not a lots of little innovation kind of project. That's a really big project. Took a third of tech. That came out of my team, by the way, and is going to be available in Germany soon. In fact, 1% of Germans already have it. The rest will get it soon, by the way. We roll out stuff too. That's another way to learn. That kind of stuff. So the things you don't see, and actually I made Henrik put in his video, if you watch the videos, this we sucked at. We were really bad at. Like, I'm not going to pretend like Spotify does everything perfect all the time. Big projects, when you have tons of autonomous teams that are totally making their own decisions, and you all want them to do something at the same time, that's really hard, because they're autonomous, right? We have figured out much better how to do this. The video project went off without a hitch, and we did it without people working nights or weekends, and we did it on a ridiculous calendar. We have figured this out, but by failing at it like many, many times. And I'll be talking more about that later, how we did that, but a lot of it was actually just kind of figuring out how to do a better job of spreading context so everybody kind of knew what was expected of them, and then trusting the people to actually deliver. And then when they finished early, to help other teams. We did a lot of helping each other, but not a lot of telling people what to do. So we have all these full stack autonomous teams. What does it actually look like at Spotify? And I'm not going to change the numbers I've been saying because those are public numbers, so I can't change them for now, till we announce different numbers. So that means 70 plus teams. We've grown since he mentioned that, when he came to visit, we were at a certain size. We are bigger than that now, but we haven't told people that yet, so I can't say it. 70 plus teams working autonomously. Over 600 developers with product and design, over 700 folks in the squads, in 5 development offices in Sweden and the US, building the same product, right? So this isn't, this isn't Rocket Internet where you're building lots of products and lots of companies. This is lots and lots of people building the same product in an autonomous way. If you can think back to that architecture slide, imagine 70 teams trying to build into that and what kind of mess that would be. We actually had to change our architecture, which was the desired goal. We were doing a reverse Conway maneuver, and I'll talk a little bit about that part next, because we actually had to change our architecture so that we were way more loosely coupled, because otherwise autonomous teams couldn't do stuff independently. So I'm going to talk, it's funny, I didn't know anybody else was talking about microservices, but I guess we all talk about microservices all the time now. I'm going to talk about microservices, but I'm not going to spend as much time on it. That's one of the things we did. When we started, or let's say you're actually, let's say you're just starting, you're building your own startup, and you have a cool iOS app and a backend. So you're just talking to a server, which talks to a data store. That's cool. That's the way we build software for many, 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 many years. Your app starts to get popular. Now, okay, you're scaling okay with that single server and that single backend database. But maybe part of your database is starting to not be able to keep up. So you shard, or you create new instances and have eventual consistency, all the standard tricks we do to kind of handle that scaling. Now what happens is, okay, you're getting even more popular. Maybe now partly what you're having happen is your server's falling over, your monolithic server application. Spotify, by the way, for many, 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 many years, wow, we're not nearly that old, for quite a while, was built with a monolithic server application, looking very much like this. And eventually, we couldn't scale it anymore. We couldn't get instances large enough. It was taking forever to deploy it because it was becoming so large. And if one part of it is failing like this, well, all right, in the old days, we would just throw a load balancer on it and make a couple instances, and you could scale that way for a while. But eventually, as you're continuing to add functionality in here, it's becoming harder and harder and harder to scale that way. By the way, Facebook does this still. Facebook still builds a monolithic server application, so you can certainly be successful doing that. But what I'll also tell you is Facebook has their own compiler engineers. Facebook has reinvented ways of moving large files around, put millions and millions and millions of dollars into just having to deal with having a monolithic server application and deploying it around the world, building custom hardware just to host it. We couldn't or didn't want to do that. Another way to look at it is if this part of your server is not holding up with the load, just this set of functionality, and this part of your data store is not being able to serve fast enough, well, you break things up into microservices or just smaller services, and then you can scale them independently based on your actual need. So for microservices, we have found, this is our real world life experience, it's been way easier to scale based on our real world bottlenecks. It's way easier for us to test because the services themselves are much smaller. So for example, developers who all have this, actually I have a fairly beefy machine compared to some of the developers who chose for some reason to get Air, MacBook Air. We give them the choice, they wanted something lighter. They can still run their service on that and test it as they do their development before they even deploy to our test environment. It's way easier to deploy because it's way smaller. It's also cool to version independently. I wasn't kidding when I said that Spotify ran on internet-connected lamps. It absolutely does. There's a lamp that runs Spotify. And what I'll tell you is they don't update the firmware on that ever because it's a lamp. And so it still is expecting to talk to an endpoint that we haven't done anything with, an API version we stopped doing a zillion years ago. Well, if you have a big monolithic server, you actually have to support the different endpoints in that API, and you have all this stupid code lying around that you don't want anymore, or you're trying to emulate it in a way that's not going to break this lamp. Instead, we can just leave those services running, and then when finally that last lamp gets thrown away, then we can just shut down those instances and move on with our lives. It's also way less susceptible to large failures if you have lots of big instances running and those go down. They take down lots of stuff, not just their own thing. And like I said, we like to minimize our blast radius. What I'll actually tell you is that at any point in time, like right now, there's probably about 15 different incidents happening in various data centers around the world, like tons of services are failing, and users never see it. Then the number of user visible incidents we have is near zero. And the reason is because we have lots of these small services. One of the teams in my tribe is the search team. And so they have a service called Search Suggest. And that is you're typing in the search box and you get suggestions. Oh, you're typing DRA. Oh, that's probably Drake, right? That service could fail and you probably wouldn't even see it. One, it'll just go to another instance. It may go to another data center. But even if all of those instances gone, we had a horrible deploy, we just killed it, you just won't get those suggestions and you probably won't even notice, right? Maybe you will, but you'll go like, oh, that's weird. And then 5 minutes later, we fixed it and it's back up and you'll go, oh, well, I didn't even notice it. That kind of stuff is really nice. If when it used to be Spotify, it was Spotify and Spotify went down, you saw it, you knew it because nothing worked. By the way, the one thing talking about going from monoliths to microservices, the cool part about that is if your service is failing all the time, which it was when it was a monolithic service, the cool part about that is you get your client code really good at handling failure. So the other reason why you'll not normally ever notice failures is because tons of code in the client that's just assuming that like a nuclear bomb is dropped on the data center or something, and it'll just pretend that everything's cool until it actually is cool. And you never even knew. The bad part, by the way, the other part about this that's cool about microservices, which I forgot to add on the slide, is a team can own these microservices, a small team, a team with maybe 2 back-end developers instead of 15. And in fact, the search team, which only has 2 full-time back-end developers, actually owns like 12 or 13 services that have hundreds of instances running, for example. So they are harder to monitor because we are literally hundreds of servers with multiple instances. We have thousands of instances running across the world. So if you can imagine the monitoring overhead on that, it's pretty significant. And noticing when one of these things goes down, which is also, by the way, one of the reasons that they'll go down and you won't notice it is because they went down. We didn't notice it either because nobody's calling customer service. You need really good documentation. If you start as a back-end engineer today at Spotify, there's hundreds of services like it, but you need to do something. Which service do you talk to? We have to have really good documentation for that. And there's latency, right? Because now we've gone from just talking to a single API endpoint to actually talking to an aggregation service that's talking to lots and lots of microservices and then collecting the data and passing it back. So we've added some latency. Yeah, we just deal with that. And it doesn't, by the way, there's no panacea, going back to Clippy. If you write, you can still write really crappy microservices just like you wrote crappy monoliths. But again, like one bad developer can write one crummy microservice, but at least they're not destroying the whole monolith. On the client side, it's a little bit more challenging, right? So it's way easy to take a monolithic backend service and turn it into literally hundreds of microservices. It's another thing to take the client. We can't split the client up and give you 55 different clients like, oh, you want to search? Well, here, run this app. And you can get your search result, and then you can copy and paste the URI and go into the playing app or something like that. This is a fairly recent screenshot of the Spotify client. I think everything that's in this is actually off my desktop. I think everything's been released in here. Yeah. So what you don't know, what you can't see here, hopefully, it looks like it's a product written by one team, right? It looks like it's written by that desktop team. In reality, it's written by lots and lots of teams. Each of these pieces is literally owned by different teams, and I actually simplified it because even like that bell is owned by a different team than this, and yeah, it's crazy. But what you don't know is, so this is all owned by, each one of these boxes is owned by a completely different team in different countries who barely ever speak to each other, right? But at the same time, it needs to look like it's a product written by one team. So that's a big challenge for us. And how do we actually create an architecture that lets us do that? So this isn't like, to be honest, this isn't like massive rocket science, this thing we've figured out. You would figure this out too, but it's worth actually talking about real quick. So of course, we have a set of shared frameworks we use. Now that isn't the same thing as a core library. We actually do have a core library. That's not what I'm talking about. I'll explain a little bit what those shared frameworks are. But then, yeah, here's our feature teams, and then we have, as I mentioned, these teams that package up the app and ship it to the app stores. Now in these shared frameworks, they're doing a few things that actually help us stay consistent and actually build a product that looks like it's written by one team. One, that we actually have very, very hardcore user interface guidelines that the UX team publishes so that we know it doesn't describe the UI. It's not a spec for the app. What it is if you make a button, this is the way the button works everywhere else in the app. If you're changing this, then you're probably doing something wrong. So we have those kind of user interface guidelines that our designers work with. We also have, obviously, a library of common UI components. The way we do it is actually we make a new thing in search, and then we make a new thing in the artist page, and they're very similar, and then those teams go, hey, I just noticed you did this. Yeah, we did. Oh, let's share the code. Oh, okay. Then a third team says, hey, that's pretty cool. Can I use that too? And then eventually we just go, yeah, that's enough power to the shared open source frameworks. And we also have shared testing frameworks. And if you can imagine, actually, we didn't until a few months ago. So up until a few months ago, literally every one of these teams had their own unit test frameworks. And they would all run as part of our continuous integration loops. But this team said, hey, we like this one. This team said, hey, we like this one. We like this one. And they're all autonomous, so they can make that decision. Because why couldn't they? But at a certain point, it was starting to become really painful to actually get CI working, because everybody was using these crazy ass frameworks instead of just. And eventually, we kind of had to say, please, we've been doing this for a long time. Let's just pick one. So we all got together, and all the teams got together and said, all right, we'll pick this one. And then we moved everything to it. But this was a pretty recent development. On the app release side, so they actually do, each of these teams is absolutely responsible for the quality of the stuff that they do. We still need somebody looking across the app and saying, hey, your button does something, jumps around when, and that was appropriate for your feature, but it doesn't make any sense in Spotify. So there is an actual team that looks to make sure we're not doing crazy stuff. Integration testing as well, they're making sure. That's actually new, by the way. We used to, this also, in the spirit of autonomy, we also used to, each of these teams had their own feature branches, which was a mess if you've ever worked in that way before, because we release every 2 weeks. And if you can imagine, the 10 minutes before we would build our beta builds for our beta users, everybody would try and integrate at the same time, and it was a big mess. So we actually moved into a single tree, which makes a lot of sense, but we didn't do it until pretty recently. And they actually take the app and submit it to the app stores, because that's not something every team can do. One thing I'll actually tell you, though, we rewrote our desktop client to a brand new architecture over the last year. Before then, we actually had something we had called the App Store that ran within the desktop client, which meant that any team, any of these feature teams, could actually push their own feature directly to customers through our own internal App Store, which we loved, because these guys could deploy their features to the desktop or the web as 10 times a day, but actually turned out to be a massive pain in the ass, because everybody's deploying stuff to the desktop all the time, and users are just constantly seeing this, please restart Spotify. There's all these cool new features you can see. You still see that, but not nearly as much as you used to. So we also changed how that works a little bit. And then, as I mentioned, we moved to a shared development tree. And we also do with guilds. If you've heard about Spotify, you've heard about guilds. That's one of the ways we do best practice sharing, to make sure that all the iOS developers at least talk to each other on an occasional basis so that they can share cool stuff together. So just to sort of sum up, what I talked about monoliths as talking about not only server monoliths or client monoliths, but also team monoliths, schedule monoliths. There's a current theme which I've learned after doing this for many, many, many years, which is that this whole way we used to work, where we'd have these massive things and break off massive pieces of innovation that most of the time, certainly by the time they shift, were not very innovative. What we've learned over time is that breaking these big things up into smaller things actually tends to work way, way better and produce more innovative and more interesting products. So anytime you come to a point where you're working with a product person or you're working with a developer and they're saying we should do this, but in order to do this we need to rewrite the entire framework that we were built on. It should take 4 or 6 months, but it will be so much better when we're done with it. Yeah, that's a good time to say, well, maybe there's 15 things we can do along the way that will teach us whether this is even a good way to go. Anyway, I'll take questions now. Thank you. Thank you. Go ahead.
Hi, Kevin. To me, it seems like you kind of you are shifting to from team autonomy to more like standardization or something similar, at least in some parts.
No,
so,
yeah.
So, is there a plan to continue doing that, or how do you see future, like say in half a year, in a year, or in 10 years, whatever?
So,
Thank you.
yeah. Thank you. Thanks for the question. I think that's interesting that you get that perspective. I think that anytime we talk about changing anything at Spotify, and we change stuff all the time, there's always that question, like, are we damaging team autonomy? And people get really worried, like, oh, like, we now have an expense reporting policy. Like, you're destroying my autonomy. You know, it's just like, well, you tried to expense, getting your nails done. And that's not a good thing. I think that, no, mostly what we're trying to do is actually enable autonomy. So in the end, like, what we're not doing is telling teams, like, you have to build this feature this way, ever. We would never do that. But what we're trying to do more of now is do that alignment a little bit better, right? So you may have I think Henrik even talked about this idea of aligned autonomy, right? Part of the problem we had at various points was that these autonomous teams had no idea of where the product was going. They each had their own individual vision, and they were all kind of going off in different directions. But in the end, users don't care about that. They want a cohesive product that feels good. There's two ways to do that. One is to impose a design on them and say, you're building this, like we did at Microsoft. The other is to say, like, look, long term, this is what we want the product to be able to do this at a very high level. What can you do to put us on that path? And that's your decision. So it's a little bit more giving them context and a little bit less telling them what to do. So in the end, everything we're going to do is in service of team autonomy, always. But mostly what we're trying to do is minimize blast radius by giving teams more information or more high-level direction and letting them figure out the details. Yeah. All right, here we go.
So my question would be, you talking about autonomous teams, but I didn't hear anything about ops. So when the team, when the team builds the application, who is run it after? Like, do you throw into another side of the wall to ops, or your team is monitoring? And also another question additional to it, how you monitor the microservices. If something fell down, the team is responsible for?
Yeah, but that's back towards ops, right? So we actually did have, not that long ago, we actually had a centralized ops team. And that was, actually when I joined the company, we had a centralized ops team. And I thought my teams I'd created at Adobe were DevOps teams. And I thought this was a bad idea. And so, but luckily I wasn't the only one, like we were actually moving towards that way. What we found with the centralized ops teams is with hundreds of servers and hundreds of instances, like they couldn't actually debug anything that wasn't obvious because they didn't have any detailed information. So almost all the time, developers were getting called anyway when something would fail. So it also didn't promote like a really strong quality focus on the back-end developers. If you can imagine, we have created an extremely fault-tolerant server environment and a very fault-tolerant client. Back-end developers, like if your service fails, like whatever, nobody's complaining. But the problem was people were complaining, they were just calling the ops folks. So we moved over the last year, actually it's been done for quite a while, we had a project called Ops and Squads. So now each one of those feature teams is operationally responsible for all their services. When a failure happens, the team gets called. And that actually means that they're much more conscious of their quality. What? You build it, you run it. Yeah. The one thing we did, and this has to do with our autonomous teams and the fact that they're full stack, because there isn't a team of 15 developers. There's 2 back-end developers and a feature squad often, but they have like 8 services. And then we don't want them to be on call 50% of the time. So one thing that we did is we use our chapters as the back-end rotation, because the chapter will have more like 8 or 10 people in it. So the chapters will actually do the rotations, and that means in the chapter, all the back-end engineers have to learn each other's services, which is also like a really positive thing, because then we get lots more eyes on stuff. Yeah. Last question.
A follow-on question from the DevOps.
Yeah.
Was it a hard culture change with regards to switching from what you had before?
So honestly, I'll be 100% honest. It was some individuals had a harder time with it than others. Like I said, like I was actually surprised because I came from we were doing DevOps in my team at Adobe, and I just assumed this is what everybody did now. And coming to a world where that wasn't the case was weird to me. And for a lot of folks, like they totally got it. They jumped, yeah, like awesome, we totally get it. And there was a small group of folks who were like, I have to be on pager duty. I don't want to get called in the middle of the night. That was just education, just working with them. The vast majority were like, yeah, cool, we get it, we understand it. And yeah, that's the way a lot of places work. So they also understood, like, we're behind relative to other companies. This is the way people work now. Once they start realizing, like, if my stuff breaks, I get called, their stuff stopped breaking a lot. So it's a really beneficial thing. All right, thank you.